Yeah, comes on everyone. Let's start off. Great. So this was the last thing that we did. Perfect. Great. Next thing. Angle of repose. So you're going to take an incline here, and when you put a block of mass m, if you see these forces here, we have mg sine theta, and this is your friction. Since it is in equilibrium, if it is in equilibrium, we'll have F is equal to mg sine theta, and this must be less than equal to mu n. This is for no slipping. And in this case, n is mg cos theta. So mg sine theta is less than equal to mu mg cos theta. So from here we get tan theta is less than equal to mu. So this angle, which is theta is equal to tan inverse mu, is called angle of repose. Meaning at this angle, if you exceed this angle, the body start going to slip. So up to this angle, there will be no slipping. So what this means is, if the angle of inclination is greater than tan inverse mu, body slips. That's the meaning of angle of repose. So example, let's say mu is equal to 1 by root 3. So the angle of repose would be 30 degrees. That means if you take an incline of 15 degrees and if you take an incline of 45 degrees, if you keep the block here, it will be at rest. If you keep the block here, it slides. But that's what it means. Clear? Now, based on this, we have few cases. The first one is the height of a sand cone. If you ever gone to a beach, right, and you try to make a castle kind of thing, so what decides how much high you can make a sand castle is this. So if you make a thing like this is the height h, this is the radius r, this is angle theta. So the sand grains which are present here, again the same force, this will be mg sine theta, and this will be your friction F max. So if this value exceeds angle of repose, so tan theta would be h by r, that will be also equal to mu. This is the relation between height of the sand cone versus radius. So the sand in the beach, right, is pretty smooth, so friction is very small. That's the reason if you try to make a sand castle, in this thing in the beach, you will see it will be very broad, isn't it? You try to make more height, you need to put a big base. But if you try to make it with clay, clay has very sticky and has a very high mu. You can make pretty sharp cones like this. But if you want to make the same height ka cone, in case of a regular sand, the base becomes pretty broad. So what decides the ratio of height by radius is the coefficient of friction. So this is one thing they can ask you. Then insect walking in a bowl. Again, here we're talking about something like, a human or something. Let's say we don't have any, special kind of legs. For example, if you see spiders and lizards, right, their legs are something like suction cups. That's a completely different concept. So if you have a bowl like this, and in this, if an insect is trying to walk, you need to understand the force which is responsible for you to walk is friction. So friction is actually trying to take you up. And who is dragging you down is mg sine theta. Again, the same logic. The maximum angle you can climb is angle of repose. So you can play around like that. Clear? Let's say a question how they can frame. Turn in the page. Let's see a question. We have a bowl, which is not a circular bowl. Let's say y is equal to x cubed by 3. Coefficient of friction mu is equal to, let's say, half. So our insect is trying to climb with this thing. Insect is trying to climb. So this is 0, comma 0. So the question is, what is the maximum height the insect can climb? So basically, this is what happens, once you reach the top, right, your legs are simply slipping like this. It's like you're doing a moonwalk there. The friction has become equal to mg sine theta. If you go anything more, friction becomes less than mg sine theta, you will slide. So at that point, right, you cannot go anymore. You're sliding like this. So find the maximum height the insect can climb. Let's get this. 1 by 9 root 3. We have one answer. Anyone else? Try. I'll give another 30 seconds. One by root 3. Let's see. Idea is the same. The insect can climb up to angle of repose. So at this point here, if you try to draw a tangent, angle theta, so the insect will think this is like an incline. So the one who is dragging down is mg sine theta. The one who's trying to take you up is a maximum friction you'll reach there at the highest point. That is mu mg cos theta. So we get tan theta is equal to mu. But tan theta is nothing but dy by dx. And mu is nothing but 1 by 3. And dy by dx is x square. So from here we get x is equal to 1 by root 3. So you want to find the y coordinate. Y coordinate is x cubed by 3. So that is 1 by 3 ka 1 by root 3 whole cube. That is 1 by 9 root 3. Clear? That's it. So just use the angle of repose and you're done. The idea is always the same. You can climb maximum up to an angle of repose, but here the angle is changing at every instant.
Sir, since the slope is 1 by 3, and we take y and x coordinates as a and 3a and then substitute it in y is equal to x cubed by 3 to get the coordinates?
What are you saying exactly? Arey God, that means this line you're talking about. That line and this line are same. You're saying join a line from origin to this point, na? That's what you said right now.
Okay, sir.
Isn't that what you did? You took this as y and x and you tried to find that. उससे कुछ sense नहीं है ना? You're saying I will take the y and x coordinate का ratio as 1 by 3, isn't it?
Yes, sir.
It means you're assuming line is passing through origin.
Okay, sir.
Y is equal to mx, na? That is the thing. Next one. We have a hemispherical bowl. Friction mu is equal to root 3. So someone sprinkled dust. And we observe after the dust is sprinkled, only this part of the thing is covered with dust. This is the area covered in dust. The entire sphere was not covered in dust. Only a part of it was covered in dust. Find the area covered in dust. That shaded area. Radius is r. How do we do this? You need to know something here. Without that, you can't do. Calculus. Do you guys remember this formula? The shaded part. This is the area that I taught you. Area of a part of a sphere. 2 pi r square 1 minus cos theta. कुछ आ रहा है memory में? And I told you also the shaded area. This was the question, the answer that I gave. So refer this thing. This is the area you should remember. Page 110, calculus. So first thing, why does the sand doesn't stick? The reason at this point, right? This mg sine, this is angle theta. If I take, this is mg, this is theta. If you look at the components here, this would be mg sine theta. So at this point, the friction has become maximum. If you exceed this point, the mg sine theta will dominate friction and will start sliding. Basically, this is the angle of repose. Again, same story. So we get tan theta is equal to mu, and mu is root 3. Theta is 60 degrees. That means on this sphere, this is covering an angle of 60 degrees. And we know the shaded area, the curved surface area, the formula is 2 pi r square 1 minus cos theta. This is the formula we derived for part of a sphere. That's it. You just need to substitute there now. 2 pi r square, angle is 60. That is our answer is pi r square. Question looks easy if you know the result. If you don't know the result, it becomes an advanced question. Clear? There, the calculus came to bite you back. You didn't realize it, you forgot. This will come again in electrostatics. This will come again in ray optics. This will come again in modern physics. This same formula will keep repeating at least 3-4 times. It will come. Quite a useful one. Don't forget it. So there are some people who teach this something called solid angle. They use that and teach. It's not there in the portion, and I don't take the solid angle. This is cool. Keep this in mind. Helps you a lot. Saves you time. Clear? Should definitely go back to the derivation and check it out in case you forgot. Next one. Turn in the page. So these are all based on angle of repose. So the story is the same. Once you exceed that angle, you'll start slipping. That is the whole point. Let's see one more. We have a wall here. We have a floor here. Friction is mu. So we have a chain. Like this. This is L by 3. Mass of the chain is M. length is L. This angle is theta. Gravity is there. Friction mu is equal to, let's say, half. The chain, find theta. If the chain is about to slip, meaning little disturbance, and this chain will become something like, it will become loose. The chain on the table will slip. Is the diagram clear? Find theta if the chain is on the verge of slipping. Means all you need is a little push, and this chain would start sliding like this, and then it will fall down eventually. There is a possibility. Let's get this. Last, give me a minute. Tan inverse 4. Yeah. I don't know. Anyone else got tan inverse 1 by 4? Okay, we had two different answers. One of you is wrong. Tan inverse 4 or tan inverse 1 by 4. मतलब 4 तो आ रहा है. I'm getting a feeling it is 1 by 4. 4 थोड़ा बड़ा लग रहा है. Feeling है. Can be wrong. Anyone else got any force? Devansh, Abhinav, Arush, Ignajit, Ojas. 3 by 8. Answer changed. We got tan inverse 4. We have two tan inverse 4s. Interesting. Let's see. Let's divide the problem into two parts. Let's cut the chain here. Right? So now if you cut the chain there, the problem becomes like this. This part of the chain is hanging like this, and this part of the chain is like this. Now, if you look at the forces, at this point, we have the tension T here. This is angle theta. This is also theta. So this component will be T cos theta. This component will be T sine theta. And since this is only 1/3, 2/3 of the chain, the weight must be 2 mg by 3. And here the tension will be some T1. The same tension T1 will act here, and this will be the friction maximum because it's on the verge of slipping. And this weight will be mg by 3. This would be the normal reaction. So T1 must be F max. F max is mu mg by 3. Mu is half, so mg by 6. There I got T1 ka value. Now for this guy, if I write the equilibrium condition, T cos theta is balancing 2 mg by 3. T sine theta is balancing T1. divide them, then I'll get tan theta is T1 by 2 mg by 3. But T1 is nothing but mg by 6. This is 2 mg by 3. mg goes up to 1 by 4. Yep. Please check. I think you did everything right. Maybe by division you messed up. There, you got it. Process is right. Check it out, everyone. Is this clear, everyone? So you just divide the part into two problems there, the hanging part and the part on the table. So the reason this thing is trying to slide is because of the T1, and the T1 is coming because of the weight 2 mg by 3. Clear? Next one. Any doubts on this? Great. Turn in the page. Pratik, clear na? Ansh, Arush, clear? Next thing. This is a good one. Let's see. We have a conveyor belt. So the conveyor belt is going with constant speed, 10 meters per second. Ever seen in the airport the travelator? Like that, a travelator. Like escalator is the thing which you go up, travelator is the thing which will take you horizontally. So this is length L. Coefficient of friction is 0.2. And this travelator is at a height of 80 centimeters. Now what you did, you took a block here of mass n, initially at rest, and gently you dropped on it. And then this block started sliding. And when it came to this corner, it went away and fell on the ground. This is your range. Okay. So block M is gently placed on the conveyor belt. Right? Which is moving with 10 meters per second. Can you tell me how will the friction be on the block? Right or left? The block leaves the belt and falls on the ground. Plot the range versus L. L is the length of the belt. How will the friction be? Right or left? Again, try to understand. There are two surfaces, the belt and the block. Who is going faster? The block velocity is 0. Belt is going with 10. So what should friction do? It should support the block and oppose the belt, right? The friction is actually forward. That is the reason the block goes forward. That is the reason when you stand on the travelator, you go forward. And that is the reason the belt actually slows down. But in order to keep it running, we have machines inside which will maintain the speed. Clear? The friction is actually trying to slow down the travelator, but because of the motor inside, the speed is maintained. Let's get this. It's a good one. Find the range as a function of length of the conveyor belt. And so the longer the belt, the more you'll travel, more speed you get, so more range you'll get. Something like that. Okay, you think, let's see. There's a trap here. I don't know whether anyone figured it out. There is a big trap there. See. First, let's see what is happening here. So initially, if you see the free body diagram, the friction would be forward, this friction is backward, and this is maximum because it is slipping. Initially, your speed is 0 and the belt ka speed is 10. This is mu mg, and this is your acceleration. So F max is equal to m into a. So mu mg is equal to ma. A is equal to mu g, and mu is 0.2, so 2 meter per second square. Perfect. So as this block here, initially it started with speed 0, but it has an acceleration a is equal to 2. Once you reach this corner here, you gain speed v here, and the length is l. So v square minus u square is 2as. So v square initially is 0, 2, 2, and l. So we got v is equal to 4 root 2 root l. Perfect. Clear? But there is a problem. This is not true every time. Now tell me one thing. What happens when block reaches the speed of 10 meters per second? When block reaches 10 meters per second, what happens? Friction suddenly becomes 0. Why is the friction acting in the first place? Because there is a relative motion. Once the block speed becomes 10 meters per second, the same as the conveyor belt, is there any reason for friction to act? They're going together, isn't it? I hope that is making sense. So there is a catch. So when the block reaches 10 meters per second, friction becomes 0 and block starts moving with constant speed. This is what actually happens on the travelator. You won't keep on increasing speed forever. There is a limit. You can't exceed the speed of the travelator. Then you have to start walking on your own. If you're just standing there, you can't exceed that speed. Block goes with constant speed 10, meaning you do anything, you keep the block there, you cannot exceed the speed of 10 meters per second. That means when I take V, 2 root L is equal to 10, I get length of the conveyor belt is 25 meters. So building a conveyor belt of length more than 25 meters is useless, isn't it? You're not gaining any more speed. I hope that is making sense. So if the length of the conveyor belt is less than 25, then the speed will be 2 root L. But if the length of the conveyor belt is greater than 25, your speed is 10. Is that making sense, everyone? The most common thing that we miss is we forget, this formula gives you an illusion the speed can keep on increasing. Just look at that. If L is 100, how much is it giving? 20 meters per second, right? But does that even make sense? Why the hell will you go faster than the conveyor belt? Your job as a friction was to make sure both are going together. Initially, this was 0 and you are 10, so you helped him. The moment you reach 10, why do you want to help him anymore? Isn't it? So the speed would become V is equal to, we get a range now, 2 root L when the length is less than 25 meters, and then speed is 10 meters per second when the length is greater than 25 meters. And now this problem becomes like a building problem. You're throwing with a speed V, you're falling on the ground, and this height is 80 centimeters. So the time of flight is root over 2h by g. That will be 2 into 0.8 by 10. That would be 0.4 seconds. Therefore, from here we also get range. R is Vt. So this also has a limit now. So 2 root L into 0.4, that is 0.8 root L. This is valid for the length less than 25 meters. But if the length of the conveyor belt exceeds 25 meters, the range cannot exceed more than 4 meters. Is that making sense? So if you try to plot the graph, so the first part range is R is 0.8 L. This is a parabola. R square is equal to 0.64 L. So this is looking like, x square is equal to my graph. X square is equal to 2ay. It's a horizontal parabola. till when? Till 25 meters. Once you exceed 25 meters, it becomes a line.
Sir,
Is this clear, everyone?
won't it be y square is equal to 2ax?
Sorry. Y square is equal to 2x. सही बोल रहे हो. This is a horizontal parabola. Y is equal to x square will look like this. Y square is equal to x will look like this. Is this clear, everyone? Did you get the catch? So most people will get the first part and they think the answer is over here. So their options would look like this. This graph will just keep going up. That won't happen. You can't exceed 20, 4 meter ka range. So this value is 4 meter. So building a conveyor belt more than 25 meters is useless. Is this clear? Any doubts on this? Clear, na, Ishana? Niharika? Daksha? Arush? Clear with this? Jainil? Sharman? Next one. Going ahead, Surya. This is your top view. So we again have a conveyor belt here. Moving with a constant speed, 3 meters per second. This belt ka speed is 3 meters per second. This is the width of the belt, which we don't know. You can treat this as your x-axis. You can treat this as your y-axis. You're getting now? How is the thing? It's like this, the conveyor belt. This is just going like this. This is just going. And now what you did, you took a coin and you projected straight like this with 4 meters per second on a belt which is moving. And the coefficient of friction on the belt is 0.5. Is that making sense? You projected it perpendicular to this, meaning if you look at this, the conveyor belt is going left and right. The coin is coming towards you. I hope you're able to visualize. Scenario is clear. So
Can you show it again?
So the coin here enters perpendicularly. Look at the diagram here on the page. You're not able to visualize this. Exam mein isse aayega. What you're not able to understand here? Coin enters perpendicularly to the velocity of the belt. Exam mein who is going to come and show you the actions? And when I'm showing you what you're doing. Are you still not able to visualize?
No, sir. Can you show it once more?
Tell me what you didn't understand.
So
Let's try to improve your imagination.
Like we are sitting on the belt and then we are throwing the coin.
Why? Read this thing.
Okay, ठीक है.
You're not sitting on the belt. The coin कैसा जा रहा है? This is your conveyor belt. This is your coin. So you projected the coin straight. You project kiya. You projected it, but the belt itself is going this way. So it won't go straight. Making sense? It won't go straight.
ठीक है, sir.
Now find minimum width. Listen, when I'm explaining the question, you guys need to listen. If you guys are doing something else, then this is what will happen. So that the coin, and don't worry about writing the notes, you're getting the PDF. Focus on listening, understanding, and solve. Find minimum width so the coin does not cross the belt. Meaning, when you're throwing it 4 meters per second, there is a possibility, right? If you look at this again, there is a possibility as the belt is going like this, there is a chance it might fall down, right? You don't want that to happen. So then what is the minimum width of the belt? And during this process, find the minimum speed of the coin. With respect to ground, this will be an advanced paragraph question, right? 2 questions. Anyone didn't understand the diagram, please ask me. Just give it a try. There's an Amazon parcel. I'll come back in a minute. Let's see. The first part someone said is 1.6. That looks weird. I don't think so. How is the friction acting? Now see, trying to do this in the ground frame is a pain. We really don't know how it is going. But tell me one thing. If I stand on the belt is going with constant speed, right? The acceleration 0. So there is no pseudo force, isn't it? The belt is also an inertial frame. So try to solve the problem with respect to belt. Again, remember, friction doesn't oppose your motion. Friction opposes relative motion. So friction won't be like this, huh? If you have thought friction aisa hoga, that is wrong. Friction opposes relative motion. So आपको relative velocity निकाल के उसका opposite डालना पड़ेगा. That means if you stop the belt, you will think the belt is going with 3 and 4. The coin is going like this, right? The friction will be like this. Friction is not acting opposite to the coin ka velocity. It is acting opposite to relative velocity. So friction is acting at an angle like that. Try. I'll give you a minute or more. Then I'll show you the first part. The second part is a pain actually. First part is still fine. Normally that's what happens whenever you have an advanced paragraph questions. One will be easy, which you can handle. Second will be tough. 1.6 is not the answer, right? 2 of you got it. Both are wrong. Why are you getting 1.6? I have to see. That is an interesting thing. 1.6. Angles kitna liya hai? You get 53, right? I hope you took the angles right. Okay. Let's see. Maybe I'm wrong. Who knows? Someone got 1.5. Think. Take a minute. I'll show you.
So what is the meaning of minimum speed? Because we have projected the coin with 4 meters per second. In the end, it's going to come to rest only.
नहीं रेस्ट में आएगा सीरियसली रेस्ट में आएगा
With respect to the country.
नहीं बट हर बार हमको ग्राउंड फ्रेम में देख रहे हैं ना तो ग्राउंड फ्रेम में रेस्ट में आएगा
हाँ नहीं आएगा
कितना आएगा फाइनली इट विल स्टार्ट गोइंग विद द बेल्ट राइट
स्टार्ट गोइंग विद 3 मीटर पर सेकंड
हाँ तो अभी स्टार्टिंग तो 4 से स्टार्ट किया फाइनली 3 से जा रहे हो बीच में देयर इज अ चांस इट कैन बी लेस देन 3 आल्सो
ओके
वी डोंट नो अभी वही चेक करना पड़ेगा वो कितना है Let me help with the first part. Solve this with respect to the belt. Why? Because friction doesn't oppose velocity, it opposes relative velocity. So better you stop the belt. Now, since velocity of the belt is constant, acceleration of the belt is 0. So luckily there's no pseudo force. So there's no problem. It is also an inertial frame. But remember, end of the day, you want velocities and everything with respect to the ground. Ishana, you got 4. Let's see. Karte. Mujhe bhi actually, I'm getting a feeling maybe I'm wrong. Let's see. I don't remember the answer. So if you stop the belt, means you're going standing on the belt. Now you'll start thinking this coin here will have a speed of 4 meters per second and 5 meters per second, 3 meters per second. So this person on the belt will think this is how the coin is going. This is the path of the coin as seen by the belt. It's a straight line. Clear? So that means this coin will have a speed of 5 meters per second. And this coin will have friction in this direction, which is F max. That means deceleration is also this way. F max is equal to ma. So a is equal to mu g. Mu is 0.5. So this is 5 meters per second square. So this coin will have an acceleration of 5 meters per second square backward. And it has an initial velocity u is equal to 5 forward. So this will travel somewhere like this and finally stop. So using the equation v square minus u square is 2as 0, 5 square, 2 minus 5 into s. We get s is equal to 2.5 meters. This is not the answer. Because what you got is a slanting length. That means in your problem here, this coin here, it went till here, and just stopped here, isn't it? You don't want the coin to fall on the other side, no? It just stopped here. That means this distance is what you calculated as 2.5 meters. But the question what we asked was the width. That was this W. And this angle theta would be, how much is this theta? Tan theta 4/3, that is 53 degrees. So sine 53 will be width by 2.5. Sine 53 is how much? 4/5. 2 meters. Please check where you guys messed up. How did you guys get 1.6? 2-3 people got 1.6. Kya kiya?
But I got 1.5 because I took cos instead of tan, instead of sine.
But you got 2.5.
Yeah, I got. But
Sir, I
You
didn't
answer
split it into components.
कौन सा components? Speed का?
Yeah, I didn't split the acceleration into components.
तो हाँ तो पूरा A ले लिया डायरेक्टली 4 के लिए,
हाँ,
इसीलिए 1.6 आ रहा है. Acceleration won't be vertical ना, it will be at an angle. वो भी कर सकते हो. You could have taken A का component this way, then you could have taken this as distance, but fine. आ रहे.
Sir, so why can't we just take it directly along the width?
What will you take along the width?
Sir, 4 meters and applying 5 meter per second deceleration.
So 5 meters is which way deceleration?
Sir, friction.
5 meter per second square is in which direction? Which direction, God? This way. Width is which way? This way. So you'll apply. तो वही
Okay,
तो बोल
sir.
रहे Puroj was saying that only ना. He was saying you should have taken the component. Then you would have got the answer actually. All clear with this? Ishana, how did you get 4?
Sir, I made some calculation mistake.
But process
I
A था.
forgot to divide. Yeah.
चलो ठीक है. I think out of all, Ansh was the most unlucky fellow. सब क्वेश्चन करके he took some weird angle and he got something else stupid only.
फिर मैंने vertical के साथ लिया था, 37 आ रहा था.
तो वही तो बोल रहा हूँ. You know how to do the full problem and then
नहीं,
mess it
sir,
up.
I took cos 37 as 3/5.
You are the type of person who will cook, do food cooking, सब cook करके last में गिरा दोगे. More disappointing. Question अभी तक हुआ नहीं. Gods, find the minimum speed. Let's get that. Find the minimum speed of the coin. See, if you didn't get the question, na, it doesn't feel bad. When you get everything in last में calculation mistake होता है ना, that hurts. वो भी छोड़ दो. Calculation mistake भी नहीं, bubbling mistake करेंगे ना, that's even more hopeless. How do you find the, again, when I say minimum speed with respect to the ground? Yeah, when someone says minimum speed is always with respect to the ground, someone got root 5. Let me show you. That is not right. Now see, the problem here is the speed which you get. When you stood on the belt, and this coin was going like this, where your initial speed is 5 meter per second, and your acceleration was 5 meter per second square backward. After reaching somewhere here, you'll have a speed v here. And we know v is equal to u plus at. So that will be 5 minus 5t. But be careful, this is the velocity of the coin with respect to the belt. Right? Now, if you want velocity of coin with respect to ground, this will be velocity of coin with respect to belt plus velocity of belt with respect to ground. Agreed? So we have to add them vectorially. Now see, this coin which I got, now listen carefully, there is a, if you add it in a proper way, you get the answer easily. If you don't add it properly, it will be a little messy. So here we got the speed v here, and the coin ka speed is, belt ka speed is 3 meters per second. Agreed? We have to add these two vectors, isn't it? We have to add this vector and we have to add the belt ka speed. So these two resultant will be the net velocity. And this angle is 53 degrees. Now, which one to resolve into components? The general feeling is v ko divide kar lete. But I'll tell you, it is better to divide 3. I'll show you why. So this component will be 3 cos 53. This component will be 3 sin 53. End of the day, you just need velocity in two perpendicular directions. Meaning this coin ka velocity will be in this direction, v minus 3 cos 53. And in this direction, it will be 3 sin 53. Therefore, speed at any instant with respect to ground will be, since this is perpendicular, root over v is how much? 5 minus 5t minus 3 cos 53. How much is cos 53? 3 by 5. That would be like 9 by 5 something. 3 cos 53 ka square plus 3 sin 53 ka square. Now, except for the fact I divided like this, rest of the part is fine. Why did I divide 3 and didn't divide v? We will talk about that. If you're okay, let's assume that is fine. The rest of the part is fine. So then, if you look at this part here, speed, this is always a constant term. And you look at here, this is the variable term because there's a time. Now you tell me, to get the minimum speed, what should happen? If I can make this part 0, isn't that the minimum speed? Because this though can never change. Do you agree with that? This part can change, this part can never change. So what will be the minimum speed? That part. So for minimum, this has to be 0. For minimum speed, this is 0. Therefore, the speed minimum, so if that term is 0, the minimum speed is 3 sin 53. Which is 3 into sin 53 is 4 by 5. 2.4 meter per second. That is the minimum speed you can get. Because a vector can be divided into two perpendicular directions in any way, isn't it? You can choose anything as x and anything as y. So in this case, what I did, I have taken this as x and I have taken this as y. Let me show you the other way around. What would have happened if I divided v into components? But have a look at this.
Sir, after you got that under root form, can we differentiate it and equate it to
क्यों
zero?
करना है? कर सकते हो, वही होगा ना. When you want to say maximum, you want to try to, right?
हाँ, so it
तो
will
बस
work.
वही end of that, see ना वही होगा. When you differentiate it, ये term तो 0 है.
Yes,
So you're saying this term is 0 na, indirectly.
yes, sir.
Yeah. Isn't root 5 nearly the same answer? So when did root 5 become equal to 2.4 God? It doesn't work like that. Did you use the same process and get the answer? Or you did some magic? That is the problem, na? Answer is not the problem. The problem is the magic. That's what I keep telling you guys. You know, when I start my own black magic classes, right, then I'll invite you guys. You can definitely learn predictions, astronomy, black magic, jadoo types and all. For now, I'm teaching you physics. So let's work only on physics. Now, let's see what happened. What would have happened if I did the other way around? The headache is if I had divided this V and this 3, this is 53. This would be V cos 53. This is V sin 53. So when I take the speed here, this will be root over V sin 53, that is 5 minus 5t sin 53 ka square plus 5 minus 5t cos 53 minus 3 ka square. Did you notice something? Both are variables. In both the things, there is a time. Then the only way to solve is maximum minimum. For minimum, you have to do dv by dt equal to 0 and then solve. Unless you made it a mess, isn't it? You would have got the answer. You would have got the answer, definitely. Kuch problem nahi hai. But did you see here? Isn't this so easy? Like, this is the answer directly. That's it. It is more of a mathematical reason than physics. I hope are you getting why I didn't do that, but I did this thing. So generally, this is a theme. See, how did I know I have to do like this? Logic Soshana. I'm adding two vectors. And I know this guy is not going to change. Only this guy is going to change. So don't mess up with the guy who's changing, right? V is changing, right? Usko wapas component divide karke, why you want to make a more mess? You're getting my logic? If you divide V into two parts, didn't you bring two variables now? You unnecessarily messed up in two different things. So keep V as it is and just change the 3 meter per second into components. Because 3 ka component is okay with it. It is constant. Are you getting the idea? वो एक है. दूसरा, this comes with experience. When you have solved enough number of problems, you keep noticing these kind of things. You will feel like, yaar, this is better. Do have a look at this. The second part of the question is pretty good. The speed. This would be an advanced paragraph worthy question. Should definitely try this on your own. Clear? Next one. This is a question from Meredo. I'm sure you must have seen in your booklet also somewhere. So here we have an incline, right? And this thing is projected with a velocity v0. Let me show you the diagram, how it looks. This is the front view. So initially, you projected this particle like this with speed v0. And this thing started going like this. You getting how it is? So that is what is showing. So this thing is going like this. Somewhere after reaching a certain point here, the speed v, this thing is making an angle phi. So he is asking, find how the velocity of the disk depends on the angle phi. So at this instant, what is the velocity? And also remember, at every instant, this is alpha, right? So there is a gravity which is pulling this way, mg sine alpha. Are you getting how it is? It's an incline. Incline pe you're projecting it this way. And here phi is variable. That angle is continuously changing. Phi is the angle with the vertical. So initially this angle was 90. Again, if you try to look at this, so this is how it is looking. See, we have the thing like this, right? And this is the thing. So you projected it this way. समझ में आ रहा है कैसा? See, normally if I leave it like this, what would have happened? This would have just come down like this, no? This would have just slid like this. But now you project it this way. So this thing is going like this. Are you getting the diagram how it is? This is sliding like this, and top of it friction bhi hai. So after going certain distance, it makes an angle phi. Find the velocity of the coin as a function of angle phi. And since it's an Erudo problem, na, symbols are a little weird. So this is actually quotient of friction mu. So that he wrote as k. So we can just take it as mu. Alpha is the angle of inclination. Think for a minute, this thing, right? You should have seen this question. This thing is just like cat dog problem. मतलब रट्टा मारना है. There is only one way to do. If you know the process, you'll get the answer, or else you won't get it. This is that type of question. So there are some problems where you literally have to mug up and say like, okay, this is the process, I have to follow this. But still, think for a minute, I'll show you. Let's see. Listen carefully. Like I said, it's difficult to figure out. You should have seen this thing once, you should know the process. So if you look at this from the side view, at any instant, look at the forces here. There is an mg sine alpha, which is dragging you down. There is an mg cos alpha, and there's a normal reaction. This is your side view. Just the forces. And the friction, remember, friction is always opposite to velocity. Friction has nothing to do with forces. Friction doesn't care about forces. Friction ka first priority is always velocity. So now, if I try to draw this diagram, I'll draw a bigger one. See. This is alpha. Let this be your x-axis and let this be your y-axis. So I'm choosing x and y along the plane. So initially, when you projected with velocity here, vx was, that was ux. Ux was u, and ui was 0. There was no velocity. Then this thing started deviating because of mg. This angle was phi. At this point, your velocity was v this way. And at the same time, the friction will be opposite to this guy, f. And we also have our mg sine alpha this way. So the things in the red are the forces. V is the velocity. Is the diagram clear? And since it is slipping, friction ka value will be F is equal to mu mg cos alpha. And it is given in the question, mu is nothing but tan alpha. So that would be tan alpha mg cos alpha, this will become mg sin alpha. The only reason this question is doable is because of this one condition. Friction actually becomes mg sin alpha. Any doubt still here? Clear? Now, let's write the equation along y-axis. The forces will be mg sin alpha minus f cos phi is equal to mass into acceleration in the y direction. So this is mg sin alpha. Friction will be mg sin alpha cos phi is may. So from here we get ay is equal to g sin alpha into 1 minus cos phi. This is your first equation. And remember, ay is the y component of acceleration. Clear? Any doubts on this page? The next thing, same thing. This time, let's write the equation along velocity v bar. Means you want to write the force equation in this direction. So in that direction, the forces will be mg sin alpha cos phi. You're dividing mg ka component minus friction. This will be m into net acceleration. Isn't it? Because velocity is changing in that direction, that would be the net acceleration. That's a velocity in that direction. So again, mg sin alpha, friction is mg sin alpha, you'll get cos phi minus 1. This will be m into a. So we get a is equal to g sin alpha cos phi minus 1. This is your net acceleration. Clear? Or you can say dv by dt. This is the rate of change of the speed. Isn't it? Because if you want in this direction ka dv by dt, shouldn't you get this acceleration then? This is your second equation. I hope you're getting everyone what we did. We just wrote two equations, one along y and one along x. If you think about it, cat and dog में something similar किया था. We wrote one equation along horizontal, one along the cat and dog का line. Now take equation 1 and equation 2. So equation 1 is ay is g sin alpha 1 minus cos phi. If you take the second equation, a is equal to g sin alpha cos phi minus 1. This is what I said. The whole reason it works is because that mu is tan alpha. Now if you equate them, you will notice ay is equal to minus a. Ay is nothing but dvy by dt. And a is nothing but dv by dt. Dt goes off. Integral dy is equal to minus integral dv. So initially, what was your vy? 0. Initially, what was this? V naught. Finally, what is the speed? V. What is this vy? So we get vy is equal to minus v minus v naught. Getting it? And now, and we also know from here the vy component is how much? Vy is nothing but v cos phi. So bring v to one side. This will be v naught by 1 plus cos phi. Isn't it? When the velocity is this way v, and this angle is phi, this component is v cos phi, which is nothing but vy, isn't it? This is the velocity as function of angle. And if you leave this for a long time, after a long time, the diagram becomes like this. This actually becomes straight like this eventually, meaning phi becomes 0. So final velocity will be when phi tends to 0. So V final would be V naught by 2. So the final speed of the coin is V naught by 2. Now we can have a look at this, what we did. So step 1, I hope the diagram is clear. The thing is going at an angle. So we divided the forces. We took x and y axis along the incline, parallel to the incline. Then we divided the equation along the y axis. Then we divided the equations force along the velocity. Then we equated them. We got ay is equal to minus a. Ay gives you only rate of change of velocity in y direction, but whereas a will give you rate of change of speed in the total speed. And then we said Vy is nothing but V cos phi. So that way we eliminated Vy and got V. Have a look at this. There, have a look at each one. There is no other way to do this. You should know like, oh, this question I have to do like this. And the reason I'm telling it works is because of f became mg sine alpha. If that doesn't become mg sine alpha, you won't get such a neat, they got eliminated. Did you observe? You literally, cos phi got eliminated from the equation. Or else it would be in a big mess. Clear? Great. Let's say a question. Do make sure to try this again. Check it out.
Can you show the first page of this question for a second?
Yeah.
No, the third one. The next one.
You said first page.
Bus. Sir. Okay, so thank you.
Chalo, next thing. We have two blocks here. The ground is smooth. This is 3 kg here. This is 2 kg here. This friction mu is 0.2. We are applying F is equal to 4 newtons. Three kg, 2 kg, mu is 0.2. This time we are applying F is equal to 20 newtons. The question is, the ground is smooth. Find the acceleration of the blocks. Max F so that the blocks don't slip. Let's get this. What do you think, Ojas? What do you mean the whole system here? I'm confused. There are two blocks, 2 kg, 3 kg. Can you show me how can you apply on the whole system?
No, I meant, are they applying it only on the 2 kg block, or are they applying
That's
it?
what I'm saying. That's what I'm saying. So you tell me that. So let's say when I catch you and pull you, am I applying force on whole your body or applying only on your hand? What do you mean by that?
No, I didn't mean it. I meant that are we applying it on the 3 kg block or on the 2 kg block? The
In the
force
diagram, where does it look?
on the 2 kg block.
So what makes you think it is 3 kg in any way?
No, I just wanted to confirm.
मतलब you think somehow ये ऐसे जाके इसमें चला जाएगा?
No, that's why I wanted to confirm. Okay, sir.
क्या confirm करना है? God, it is made so clear there. Get better doubts na re. Exam में ना these kind of confusions will unnecessarily mess up your timing. You will start. You guys think all weird things. You know what I feel like sometimes? It's like this thing. See, there is a path. I dug a trap for you here. Okay? And I was thinking, yaar, ye log aake isme girenge. What you guys do na, you come like this, you go like this, then I said, shit, these people are escaping the trap. Then you go and jump into the river somewhere here. I said, like, what the hell are you doing? Matlab, that river was never there in the path. So trap chod ke you go and jump into some other thing. And I was wondering here, what the hell happened? Matlab, that's the kind of feeling I get sometimes. So let's get the first one. This is a good one, right? 2-block problems are started. This is the very good model. Today we will do some basic ones. Next class we'll do good ones of 2 blocks. Next class we'll wrap up friction. Let's try the first one. Give it a try. Find the accelerations of the blocks. Any answers? 0 and 4/3. Yes. Okay. Now see, 2-block problems, right? There is a way to proceed. So listen carefully. The first thing, when you draw the free body diagram, this is what you guys are doing. F is equal to 4. Friction is equal to 4 because that is 0.2 and 12. This is equal to 4. Okay. Now just think how absurd it is. Okay. This thing is 0 acceleration. This thing is having 4/3. Meaning the block which you are pushing, wo move nahi kar rahe. The block below it is moving. Meaning on your dining table, you keep something, you push that block doesn't move, but the dining table starts moving. You're getting what's the catch? That is one. That is big absurdity. Second thing, who the hell told you F is maximum? How did you decide F is maximum? Isn't this what the whole story of the chapter is? You can write F is maximum only when you're 100% sure both the blocks are slipping, isn't it? You cannot write F maximum until and unless you're sure 2 and 3 kg are slipping. I hope you're getting it. So be careful. So this is how you proceed with the problem. So there is a process that we can follow for this. So 2 kg, this is what you guys did. So I'll just write that down. So you wrote F max here. This was 4 and you got acceleration 0 here. And then you took, this is F max here. Common mistake happens. People take it in. That's what I'm saying. Now friction is not equal to mu into n. Friction is always less than equal to mu into n. And here we got acceleration is equal to 4/3. So the catch here is, this is wrong, first of all. Getting it? The problem is this guy. How do we know it is slipping? We have no idea whether the blocks are going together or slipping. So until unless you prove that, you don't have any right to take F is maximum. Therefore, we can't take max. So that is the first thing. So keep in mind, whenever you see 2-block problems, keep that in mind. Don't take F max. Then how do we start? This is how we start. Since we don't know whether they're slipping or not, let's start with an assumption. Assume they're going together. Assume करके देखते क्या होगा. Assume blocks go together. Since they go together, I can treat the whole thing as one big block, 2 kg. 3 kg, and this is force F. Then we get acceleration is equal to 4 by 5 meter per second square. Great. Then take any one block. I will take the 2 kg block. This will be F is equal to 4. This will be friction, not F max, just friction. Now from this I'll get F minus F is equal to 2A. F is 4, friction, this is 2 into 4 by 5. So we get friction from here, that is 8 by 5, 12 by 5 newtons, or 2.4 newtons. Now try to understand what this is trying to tell you. Friction is telling you, now see, friction is telling you, boss, I need 2.4. The meaning of this statement is, this is the required friction. The friction is saying, if you give me 2.4, I'll make sure the blocks go together. If we can give 2.4 newtons, blocks go together. That is what we proved. We need 2.4. But how much can I give? So the F requirement is 2.4, which is less than F max. F max is 4 newtons. I can give you 4, but you're asking only for 2.4. Therefore, my assumption is right. What was the assumption? Both are going together. So what is the acceleration? So whatever I did was right, done. The acceleration is 4 by 5, and the friction is 2.4 newtons. Did you get the process? Isn't that what we do normally always? You have to check how much you require. Is that making sense, everyone? Let me show you the second one. Now let's take the 20 newtons and see what happens. The second part, 2 kg, 3 kg, and when you're applying 20, again, maybe you're getting a feeling it will slip, but don't. Because once you start doing that, you'll do it for every problem. You'll get trapped somewhere. Since we don't know what is happening, assume both are going together. This is the basis, later on we'll do for 3 blocks also. This is the idea for every time. Then what will be the acceleration? A is equal to 20 by 5, 4 meter per second square. Take any one block. I'll take the 3 kg block. Basically, your job is to find the friction, F and acceleration. So F is equal to 3A. We're getting 12 newtons. This is your required friction. Friction is saying, if you give me 12, I'll make sure I'll go together. But F max is 4. I can give you only 4. So what will happen? Therefore, our assumption is wrong. So what will the friction do? And F max is 4. Now you can say they're slipping for sure. So whatever you read, all this was for useless act. It is a waste of work, but it was important. Without doing that, you won't realize. Again, you have to draw new free body diagrams. 2 kg, F is 20. Now you can be sure it is slipping. The F max is 4. This is A1. This is 3 kg. This is F max is 4, and this is A2. So A1 will be 20 minus 4, 8 meter per second square. A2 will be 4 by 3 meter per second square. Is this making sense, everyone? This is how you proceed with 2 block problems. You can also start with an assumption they're slipping from starting and then they can do, but I feel this is more comfortable. At least I liked it. इसमें कुछ confusion नहीं है, slip हो रहा है नहीं हो रहा है, you don't know, right? So let's start with an assumption and just prove it. Is the idea clear? So your job, you're trying to find always the required friction, how much you need to make sure they go together. And then we will see, can you give that much? If you can give, great. You can't give, that means you're slipping. So either way, you know what to do with the problem next. If your assumption is right, problem gets over there, you're happy. Right? If it is slipping, that is also fine. If you're slipping, at least you're sure na friction is maximum. Either way, you'll get the answer. Do have a look at this. There's still one more part of the question. So how much maximum force can I apply so that blocks don't slip? Can you do that part? Any doubts on A or B, please ask. We will do more of this in the next class, but I thought I'll show you one model for today. So 4 May you're going together, 20 May you're slipping. That means beach May somewhere you're almost on the verge of slipping. How much is that? So there's a particular force when they're going together also, and F is also maximum. 4, 1, 8. Okay, we have one answer, 8. Let's see.
Can you show the next page? Thank you, sir.
Anyone else got any other answer? We have one answer. Twenty by 3. See now, for maximum force, the moment you use the word maximum force for slipping, means you're saying the blocks are on the verge of slipping. So this is a special case where you're about to slip, you're also going together. Means you're satisfying both the things at the same time. That means you can treat them as one block because they're still going together, but the frictions are maximum. This is the acceleration. So F is equal to 5a. Take any one block. I'll take the 3 kg block. You can take any one, it'll be the same thing. I know the friction is maximum, which is 4, and this is your acceleration. So A is equal to 4 by 3. 4 only, no? Yeah. Done. So take this and substitute here. So we get F is equal to 5 into 4 by 3. That is 20 by 3 newtons. So if you apply 20 by 3 newtons, you're exactly on that verge. Both are going together, but you're about to slip also. You want, you can take the 2 kg also. You'll get the same answer. 2 kg में थोड़ा equation बड़ा होगा. This will be F max is 4. Acceleration is the same. So F minus 4 is equal to 2a. So bring that a and substitute here. So F minus 4 is equal to 2F by 5. So this will be 3F by 5 is equal to 4. F is equal to 20 by 3. It doesn't matter how you do. You can take the upper block or the lower block, answer will match. Is this clear? These are the 3 possibilities you can get, isn't it? Think about it. Either you're slipping, or you're going together, or you're on the verge of slipping. These are the 3 cases you can get. And this is how you always start 2 block problems. Start with an assumption they're going together, find the required friction. If it is less than maximum, you're safe. Whatever it was right. If you're wrong, then again you have to redraw the free body diagrams. But at least you're lucky, you know, F is maximum. You'll get the answers. Is this clear, everyone? Yeah. So that's the last one for the day. So next class when we catch up, we're going to do more of this, more of 2 block problems. We'll do 3 block problems. And that's the last part of it. So I think that will wrap up. And friction will be done in the next